Of Code Club. Let me not show you all my Google stuff. Welcome back for another episode of Code Club. My name is Pat Schloss, and this is the Riffomonas YouTube channel, and you are joining me for a live stream here with Code Club. And my goal in today's live stream is to build figures F and G, or panels F and G, from a figure that was published in the journal Nature Microbiology. The original article is titled Strain Displacement in Microbiomes via Ecological Competition. Again, welcome. Please feel free to say hi and tell us where you're joining from over here on the in the chat. I see already we've got Matthew from Australia, Rents from the Netherlands, Lily from South Korea, and yeah, so awesome. Thanks for joining in. As I said, this is part of the Riffomonas YouTube channel. And if you're not familiar, or if you've never seen this before, let me see where I put it, right there. You can go to riffomonas.org, and I will go ahead and copy and paste this into the chat. And so why I tell you this is that so you can join the mailing list. And so every week or so, I put out an email describing some visualization and how I would go about building that visualization at like a pretty high level, at like a 30,000 foot view level, right? And so as an example of that, this link here that I will also put into the chat, let's see, paste there. All right. So that second link will get you to this page. And this is a web version of the email that I sent out last Friday describing panels F and G from this paper. And I talk about it at a pretty high level. You can see that there's maybe names of functions in here, but there's really no code. It's meant to be narrative to kind of get people thinking about, okay, if you had to make this in R, how would you go about making it in R? The general cadence then I have is then this newsletter comes out on Friday, and then on Monday, I put out a critique video. And so this then is a link or a page that links to the YouTube video that I put out on Monday, critiquing the overall visualization that was described. Where are you? Too many windows. Okay. That was described here in the figure 2 of this article, right? So I go through in the critique and talk about this figure in some detail and kind of thinking about the context, thinking about how it was made, how we can interpret it, and then perhaps what would make it all the better, okay? And so again, I'm going to be focusing on F and G today. Depending on how this goes, next Wednesday, I might talk about panels B through E, okay? And so give me feedback if you'd like to see me do B through E, we can do that. If you watched that critique video, you would know that I actually was a big fan of this plot and this paper. I thought it was pretty well done. And I'll save the cartoons and stuff that I kind of geeked out about in the critique for the next live stream if I do that. But you'll notice that this style for panels F and G is what I talk a lot about in these videos, right? It's simple. It's showing the data. There are between 5 and 9 data points in each of the categories across the x-axis. I can see the points. They're not messing it up and making it complicated with box plots or violin plots or bar plots and error bars, right? They're showing us the data. They draw the median through that. And then on top, they put the p-value. Of course, they do go out to 4 significant digits in some case, which is a bit overkill. But something that occurred to me that I was interested in thinking about, and I talked about this in the newsletter last Friday, was that they use brackets in a variety of contexts, right? So clearly they use the brackets up here for the p-values. And so brackets are useful for bracketing, for grouping data or things together, right? And so this p-value of 0.5897, let's just call it 0.59, brackets this cloud of points and this cloud of points, right? And then there's also brackets at the bottom, right? And so they then have 2 layers to the x-axis. So they have the invader toxin on the, I guess, the primary, and then the secondary being the resident or a mutant, okay? And so it's not super important for the discussion or the recreation of the plot, but let me just quickly go through how these experiments were done. So in this experiment in figure 2, what they did, actually, let me go back to figure 1 because I think that's a lot easier. And this is the one I showed in the critique video. And unfortunately, because of the way Nature does their plots, I can't zoom in on this too much wider. But they're looking at invasion and what characteristics do organisms, in this case bacteria, need to be able to colonize and replace another organism that's present. Okay, and so blue are the resident population, red is the invader. And so they looked at 2 different modalities that a invader might colonize and replace the existing strain. Okay, so the first was nutrient competition. And so you can imagine that if like 2 strains use the same nutrients, then they're going to compete really hard because they're going after the same nutrients, right? But if one has a private nutrient, another has a private nutrient that's private to them, that only they can utilize, then they'll be able to perhaps colonize. At least that's a hypothesis. Another means of competition would be interference, where perhaps the invader produces some toxin that kills the resident population. Okay, so let's come back then to figure 2. If my computer lets me do this here. Oh no. I wonder, Matthew, which link you're looking at that you're getting that error message. Is that from, yeah, let me know which one, and I'll try again the link. I took the link directly from what I was showing you, so maybe try it again. We'll see. And great to have you, Patrick, back from Kenya. So again, the way they do the experiment, they inoculate with the resident population. They then bring in the invader. Again, the resident is blue, invader is red, and then they let it run for 72 hours. And so we're now looking at the data in F and G at the end of 72 hours. Again, red is the invader, blue is the resident. And so in F, they're looking at invasion, the density of the invader over here on the y-axis after 72 hours, okay? And then they're also looking at displacement. So does the resident population get pushed out after 72 hours? And so then along the x-axis, we see both types of competition. So this first layer of invader toxin is that interference competition, right? Where there's either, the invader either has an E2 colicin or the K colicin, okay? Or they don't have a colicin, they don't produce a toxin. That's what the hyphen means. And then the second layer is the metabolic competition. So the wild type is the wild type, and then the delta SRL AEB is a strain that cannot utilize sorbitol, okay? Again, it doesn't matter for recreating these plots, but hopefully it gets you thinking about, or just removes that cognitive blast of like, what is going on here, okay? So let's see, the last one. Let me try that again. So I think that was this. Oh, right. Because I updated the link. Sorry about that. Thank you for calling attention to that. And I will paste that in. And there is the link for the critique video. Awesome. Thank you for saying something. All right. Let me come back here. And appreciate your patience. And hopefully the audio situation has been resolved and we're all good to go at this point. Something to know is that at the end of this live stream, I will be posting all of the code that I generate to a blog post. And so you'll be able to go down below to the description for this episode and see a link there to a blog post where I provide all of the code that I'm generating. Also there, you will find a link to this article that you can read. It's an open access article, which is one of the reasons why I pick the articles I pick is because they are, in fact, open access. And you can tell that something is open access within Nature because it says open access. The other reason I pick the figures I pick is because at the bottom, some of them say source data. And so I can click on this link for source data. And so that will then take me to source data figure 2, which if you hover over it and then look at the bottom left corner, you'll see that that is a link to an XLSX file. So I'm going to go ahead and copy the link address. And I already have a R script created here in RStudio called invaderdisplacement.r. And I'm going to go ahead and paste that in. And so this I will call my spreadsheet. I'll call it XLSX file. And that then needs to be in quotes. And let's go ahead and do library tidyverse, because I know I'm going to be using the tidyverse before too long. And then we'll also do library read Excel. And that is a package that allows us to read in Microsoft Excel workbooks. So we can download this file manually, right? I could click on that link, download it, move it to the directory, all that stuff. But that's just, I don't know, whatever. I want to do it algorithmically. So you could get this code, run it, not have to worry about getting things into the right places. Because I find that is a big problem for a lot of people, is just getting things in the right place or even knowing where you are. So we can download this with download file, and then we give it the URL and then the name of the destination file. So the URL is that SLXX, maybe I'll go ahead and call this XLS link. And so we'll call that link, and make sure this is loaded. And then I'll have XLSX file. I'm going to go ahead and call that figure2 data.xlsx. And then I will add that as the second argument to download file. And I've got my working directory here, and I'm noticing I'm not showing you what's on the right side of the screen. There we go. So in my files tab, I see I'm not there. I'm in my home. So I think I can do go to working directory. I did that by clicking on the gear, go to working directory. And I know my working directory here in RStudio because over here in the console to the right of the R version, it tells me my working directory, right? So again, I can go gear, go to working directory, and now I'm in my working directory, and I see that I have in fact downloaded that figure2 data.xlsx. In an ideal world, I could do read Excel, and then I could do xlsx file, and that would then give me a tibble with all my data. But I am seeing all sorts of stuff that doesn't look good, okay? So I'm going to have to go ahead and fire up the workbook. And so invader displacement, figure2 data XLSX, open this in Microsoft Excel. And what you can see if I zoom in here is in other episodes, authors have put each panel into a separate tab across the bottom. Here, they put each panel into a separate table within the same page. Okay, this is not ideal, but hey, we can work with it, right? And so panel F is where we'll start, is this table here, okay? So to get this highlighted region, we need to know the upper left and the bottom right coordinates. So the upper left is B39. And so let's come back to our source. And then in here, we could do range. I gotta spell it right. Range equals B39 colon, and then come back. And then down here, we have G48. All right, so to G48. Running this now, I see that I get 9 rows and 6 columns. And then there are NA values in here. And if I look at this, I've got, I believe, 9 rows. That's actually, well, yeah, this is 9 rows. There's a header for the column titles, right? So there's 9 rows and 6 columns. And then there's some empty cells, and that's what's getting the NA value, okay? So this is our panel F data, right? And so I'll go ahead and call this in a comment, panel F data. All right, so we've got our data into R, and we are ready to go. So as I think about, let's think about figure 2. I'm, again, for now working on F and G. One of the other critiques I had of their figure was that this is the PDF version of figure 2, right, of the full article, is that they didn't use, they basically use a full page for the figure, right? For the figure and the caption, it's a full page, but they're not using the full width, right? There's a lot of extra white space. And white space is great and all, but if you've got the space, why not use it? And so what I'd like to do is recreate their plot. And I'm going to make some changes along the way for kind of my sensibilities. But largely we're going to make what they have. And I'm going to take off my sweatshirt because somehow it got warm in my office here. And so I'm going to try to make it wide while at the same time being the same height. And when we think about the other panels like B through E, you can see that those are actually more narrow than F and G, right? And we'll deal with that later. But what I'd like to do is try to make it wider while being the same height. And so what I'm going to do is I'm going to make a screenshot here on my Mac that is the same width as the caption and as tall as the two panels, okay? And so let's do that. And so that then goes to my desktop. And so hopefully that'll pop up here. And I'll drag that into Invader Displacement. And I will then call this panels fg original.png and then open that up. And so then we can see that this is what we're trying to recreate. Okay, so I'll go ahead and get rid of the PDF. This is what we're trying to recreate. And what I'd like to do is figure out the dimensions of that figure, right? So what I've done before when I was doing things from like the media, where I was trying to recreate things, is use the file function, which I think is part of ImageMagick. It might be part of Mac, but there's other ways to get the dimensions, but I'm trying to look for the pixel dimension. And so we'll do file panels F&G original. And this then tells me it's a PNG, and it's 2700 pixels wide by 736 high, okay? And so why is this all important? Well, it's important because we're gonna do ggSave, and we're gonna call this panels fg.png, and we're gonna have a width, and I'm gonna make that 7 inches. And so I have in front of me the printed copy, and I also have my kid's ruler, and it is 7 inches wide from the left edge to the right edge of the caption. So if it's an 8.5 by 11 piece of paper, the margins were 3/4 of an inch. So we'll do a width of 7. And so I now want to figure out how tall that should be. And so we'll come back to R to do that. And so again, we have 2700 by 736. I'll plop that in here, go to my console, as I said. And again, if I want, if I want 7 inches wide, so 7 divided by 2700 times 736, that will give me 1.9 inches high, okay? So we'll then do height equals 1.9, okay? And within ggSave, you can actually set the units to be in terms of pixels. I want to keep it in terms of inches because if I'm making this figure for a publication, the publication and their instruction to authors is going to tell me how wide the figure can be. And so again, I'm trying to keep the same heights of panels F and G as they had in the original so that mine isn't taller, doesn't use up more space than theirs, okay? Cool, so we've got that all set for plotting. Now what we'd like to do is start thinking about plotting, right? So we've got this data frame, and if we think about what is on the x-axis, on the x-axis we have the toxin and the genotype of the resident strain, right? So we've got basically the genotype of the invader, the genotype of the resident, okay? So that's basically what I've got in my column headings down here, right? The y-axis then are the values, the densities, okay? And so I need to get this to be tidy, right? I need to get the column headings to be their own column, the density values to be their own column, and probably need to get rid of those NA values, okay? To do this, I'm going to use a function called pivot longer, right? But I need to give pivot longer a column to pivot on, a column that is basically the same across all columns. So to do that, I'm going to go ahead and do a mutate to create a column I'll call replicate. And I'll do 1: the end function. And so the end function tells me how many things there are. So how many rows are there? And so when I run this, I now see over on the right side, I've got my replicate column. and it goes 1 through 9, which is how many rows there are. Now I can pipe this to pivot longer, and I will do everything but replicate. So I'll do minus replicate, and I'll do names 2, and I will say condition and values 2 equals density. Okay, and so now we have a 54-row data frame where we've got the replicate, the condition, and the density. I don't really need that replicate column, but I'll leave it in there because we might want to do some other pivoting wider or longer along the way. So I'll leave that there for now, okay? But we also have these NA values in here that we don't need, and those NA values that were, again, where perhaps for a certain condition they only did 5, some they only did 8, some they did 9, right? And so basically because their workbook isn't tidy, right? They've got all these empty cells in here, okay? So we can get rid of that easily enough by doing drop NA. And so now we see that that NA value went away, and we've gone from 54 rows down to 37. Okay, cool. All right. So again, as you're joining in, please say hi. Tell me where you're coming from. If you have questions, feel free to throw it in the chat. That's why I do this. I should also mention while I'm paused here that I teach workshops. I have video recordings of how to use ggplot2. And in the new year, I'm putting together workshops on data visualization and data critique in a manner that doesn't require you to use any coding. And so it's concepts that you'd be able to use with any data visualization software you want, or Python, Prism, Excel. I should also point out really quickly here, this plot, this whole figure was made in Prism, which I find jaw-dropping because I've never seen a good looking Prism plot. They're always just so clunky and I don't know, just not really nice. But I'm impressed that they were able to make this look so nice. I don't know if they maybe did some post plotting manipulation, but anyway, that's pretty cool. So anyway, like I said, there's other learning opportunities out there through me. If you want to get in touch with me, you can use the comments. You can shoot me an email, pat@rifamonas.org, and I'd love to talk more about what your needs might be. Okay, so now we have this data. We can start plotting it, right? So we can do ggplot, AES. Again, on the x-axis is the condition. The y is the density. And we'll want to think about like the color and the fill, but let's get a plot, all right? And then we'll add to this geom jitter, and that should be good. And yeah, so the geom jitter will get the jittering of the points, right? So let's go ahead and run this and see what we get for ours. And I'll go ahead and open up my version of this plot, and we will see what it looks like. Okay, well, we're on our way, right? We have, well, the data's all there. It's not necessarily how we want it, right? There's a lot that we still want to work on, including things like the y-axis isn't log scale, the x-axis isn't in the correct order. What R does, or ggplot2 does by default, is it alphabetizes the variable names, okay? And so, yeah, so that's why the SRL, which is this mutant, the knockout, goes first because S comes before W, right? And then call E2 comes before call K, which is the same as what they had, okay? So let's think about how to get started. Also, the other thing to note is that I basically only have panel F data here, right? So we'll work up to panel G. And maybe what I'll do for now is I'm going to go ahead and copy this GG save statement and comment out one version, but I'll make one 3.5 so it's half the width. So it doesn't look quite so funky, right? And we can imagine that this corresponds to the left side, okay? And gives us a better sense of what things will look like, all right? Great, Ibrahim, to have you from Algeria. Thanks for joining. All right, so let's go ahead and start thinking about the other aesthetics, like the colors and the fills. So when I look at their points on both sides, really, I see that they've got a border color and they have a fill color. And so this is my favorite plotting symbol. It's like they watched my videos and they were like, we're going to give Pat like his dream of a plot. I don't think they watch my plots. I think they're pretty good on their own without my help. And so we need to create a border color that is going to map to whether it's from panel F or G, whether it's invasion or displacement. And then we want, so that'll be the border color of plotting symbol 21. And then the fill will be whether it's, whatever invader toxin it is. And then for the resident, we'll have to think down the road about the genotype, right? Great to have you, Laurie, from Canada, and Ibrahim, another Ibrahim from Senegal. Wonderful. It's great. All right, so to do this, let's come back up here to our data. And again, we have the condition and the density. And I want to take that condition column and I want to split it up. And so there's a function, it's called separate. And I'm hedging here, or pausing here for a brief minute, because I know that it's no longer favored, right? It's still available within tidyr, but they're trying to push people towards separate, wider, position, or delim. So let's use separate, wider, delim, and I will plop that in here. And wonderful. And so the arguments for this are a little bit different. And so I'm going to look at the help, because this is how I learn things too, right? Believe it or not, I don't know everything there is to know. I'm always learning myself. So this, I think, is the first time I've used separate, wider, delim. And so the names sep, we're going to put as a comma and a space, right? Because basically the stuff before the comma is the genotype. The stuff after the comma is the toxin, right? And so here we will do a comma space. And so if we run just that, oh, I have to tell it what call. All right, so we'll do calls equals, and it's going to be condition, right? So we got to tell it what column we want to separate on, and delim must be a single string. Oh, maybe that's what it's supposed to be. It was delim. Delim not named sep. Okay, we'll get there. Like I said, I'm learning too. All right. And so now it's saying must specify at least one of names or names sep. And so here's where I put in the column name that I want those to go into. So now we'll do names equals C, and on the left we'll do genotype. On the right we'll do toxin. And because this is going over the right side of the screen, let's go ahead and put it on separate lines. There we go. No warnings, no errors. We've got replicate, genotype, toxin, and density. But I want to keep that condition column because that's ultimately what's going to be mapped to the x-axis, right? And so I could put it back together, but I see there's this calls remove column, and I'm going to guess that that is doing that. It's removing the column. So if I scroll down here, calls remove. Should input calls be removed from the output? All right, so let's go ahead and set that. Oh, I'll put that up here. Calls remove equals false. And I think that will keep, yep, it keeps my condition column here. And so now I can pipe this in and everything stays the same, right? But now I want to add in color, and the color is going to be toxin. And then fill, nope, sorry. Color is going to be something else. All right, so we'll come back to that. So fill is going to be toxin. And let's run that. And it's still black and black, but we have a legend with black, black, and black. And so what I need to do is tell geom jitter shape equals 21. And for now, I could do like color equals red. And then that gets us our 3 toxins and our red border around each of those 3, okay? So we're gaining on it, right? And maybe what I'll do is I will come back up here, and where I did mutate replicate equals 1 to n, I'm going to also do, I'll do panel, and then I'm going to go ahead and put it in capital letters. And so this will be invader or invasion. Okay. And so now what I can do is I can come down And I can set my color to be panel. Okay, so I'm going to map the value of the panel column to the color and the toxin to the fill. And so this seems silly at this point because we only have one panel, but when we bring in that panel G, the replacement data, then we'll get multiple colors. And it's upset because can't combine these things. And that's because I'm pivoting wider only on replicate. And so I need to add in, well, I think panel's off the right side of the screen. So I need to pivot longer also on the panel column. So we'll do pivot longer, everything but panel and replicate, names to condition, values to density. Good. The morning message goes away. And so now what I see is I've got the red borders and I've got the fills. I also have these two legends. I'm going to go ahead and I think turn off the legend. And I can turn off the legend here in geom_jitter by doing show.legend equals false. So that gets rid of that because again, as you can see up here on the top, we don't have a legend, right? So we'll roll with that. All right. So let's go ahead and do our best to match the colors, the fill color. And so we can do scale, fill, manual, and we'll do breaks equals. And so these are going to be the values in the toxin column, right? And so we'll do what? So the first one is a hyphen, and then I believe it was call E2 and call K. Okay. And then the values are going to be the colors. So we'll do white, black, and I'll do dark gray. And so now what we see is we've got those colors. And if I wanted to be more precise, like I think my dark gray here perhaps isn't quite as dark as theirs. As always, I can pop open my digital color meter, grab that. So that is a gray. It's all 61s. And paste that in. And then let's just, because we're here already, let's go ahead and look at that. And that is black. So black is, the hexadecimal is 6 zeros. And then the fill over here is white, okay? And I know it's got a white fill because as I kind of zoom in over here, you'll notice that like kind of where two circles are on top of each other, you don't see the bottom circle overlapping the top circle. Anyway, so, okay. So now we've got the same fill colors that they have. And those reds look a bit muted. So let me just double check the red also. And let's see, I think, whatever. This is, as I'm prone to do, this is overkill. Let's throw that in for the red. Oh, we don't have the red. Actually, that isn't red. So we can also do a scale color manual, right? So do scale color manual. So the color that's in there now is the default color, which is kind of a pinkish salmon-y color, right? It's not red. So we'll then do breaks. And the two panels that we're going to have will be invasion and then displacement. All right. And then we'll do values equals that. And then since we're here, let's go ahead and grab this blue color. Oh, there you go. And then we'll plop this in. All right. And so now we see the stronger red color for that border like they have. Okay. Cool. All right. So we're making progress, right? And let's go ahead and put things on a log Y scale, because right now these values all here look like they're at 0, and they're not at 0. It's just that these are so much higher, right? Basically these are steps of 100 million, right? And so that makes anything that's in the order of 10,000 look like 0. So we can do that. So since we're down here with our scales already, we'll go ahead and do scale log, or scale y log 10. And that'll put the y-axis on a log 10 scale. There we go. Now we can see our data shows up more or less where theirs are. Again, we have things flipped, which we'll deal with shortly. And yeah, I think that's good. So let's go ahead and let's add one other plotting element to this. And that is going to be the horizontal line through the data. Okay. And so we can get that line through a variety of ways. And so I'm going to use a function called stat summary, but I see a comment over here. Shady Smith says, is there any reason you split breaks and values into separate vectors? When the values can take a named vector, I prefer the named vector so you know it's definitely matched correctly. Split breaks and values, and oh, I see. So you're talking about down here with scale fill manual. So I have always done it this way. And maybe values is a named vector, can be a named. Let's see. Let's see. It could be a named vector. Let's try that, okay? So we could do invasion equals that. Displacement equals that. I think that's what you mean. No errors. And that got the right result. Cool. Thank you. I did not know you could do that. All right. So again, we're all learning. And maybe for consistency, I'll do the same thing up here. And so again, with a named vector, let me show you what that looks like if you're not used to seeing that. So we have for each slot in the vector, on the left side, we have the name. And on the right side of the equal sign, then, we have the value. Okay, and so again, that all works. We get the same result. But if I were to take like this vector, what you'll notice is that we get a named vector, that these are the values in the vector and these are the names. Okay, so like I said, it's the way I've always done it. I probably initially saw someone do this as part of like an online tutorial, and that's just how I've done it. So thank you. That's great. And like you said, that does do a good job of making sure everything's in the same order. Okay, wonderful. Thank you. Like I said, I always learn things doing this, and I really appreciate the input because that helps me to learn and do things that I don't know and perhaps teach some of you the same thing. So great. All right. So we got that on the log scale on the y-axis. We'll have to do some formatting. Right. We're going to go ahead and put lines through the points to show the median. And so we could do that, as I said, using stat summary. So we'll do stat summary. And then the function we're going to use is median. And I think that should work. I'm wondering if I have to put it in quotes. I don't think I have to put it in quotes. And then the geom that I'm going to use is crossbar. So the crossbar geom is the same geom that makes the box for a box and whisker plot or a box plot. Okay. And so we'll go ahead and run that. Didn't need the quotes. And so what you see now is I have a red line going through the data. And you can kind of see again the box, right, of a box plot in the legend here. And so I want to get rid of that. So we can do that over here in stat summary. I can do show.legend equals false. You can remove the legend in the theme function. I'm doing it here because that's where I started it with geom jitter, and we should be good. So that legend goes away. Of course, I want that line to be black, and I want it to be thinner. And so I can override the color from the ggplot in the geom or the stat function by doing color equals black. And so this basically overrides anything that's been specified within the AES function up above. Okay. And so now we get those black lines. Of course, those are very thick, and we can slim that down by doing line width. And let's do 0.2. That makes it thin, not as thin as theirs though. So let's go down to 0.1. And that, I think, is pretty good. That definitely narrows it down. And so that is our stats summary, right? And so one thing I notice is that our bar is at the same length as the jitter. And I don't know, yeah, we're gonna probably be playing with things as we go along here. So I don't want to get, I don't know, too far down the road, but if I look at geom jitter, let's check out the default width. And so if we come down to the arguments, let's see. If omitted, defaults to 40% of the resolution of the data. Categorical, 0.5. I think that's what it is. Or maybe it's, this isn't really helping. All right, let's go ahead and here and then do width equals 0.4. Okay, so I think 0.4 is probably what it was. Let's go ahead and bring it down to say 0.3. And so that brings it in. And then our bar is a bit, I don't know, quite a bit longer. So let's go ahead and bring that in too. So in stat summary then, we could do like width equals 0.4. And so that then is much smaller. And so the width argument isn't always the same for these different functions. So I think it's half the width. So this should be then 0.8. And now what we see is that those lines extend past the jitter of the points. The other thing that you're perhaps noticing is that as I've run this multiple times, the points are moving around, right? And so let's go ahead and make that consistent. And so within geom jitter, I can do position equals position jitter, and then the width will be 0.3, and then the set, is it set seed or seed? I think it's seed. 1976, 06, 20. It's the best seed in the world. And forgot the closing parenthesis down here. All right. Very good. And so now if I run it again, nothing changes. Okay. Cool. All right. So that's great. Now let's go ahead and switch the order of our x-axis. Okay. And yeah. So to do that, we could do scale. Well, let's come back. Hold on. So to change the order, let's do it. Well, you know, we can do it here. So let's do it here. I was going to have us make it into a factor, but I don't think it's necessary to make a factor. So let's do scale x discrete. And we can then put the breaks. And now the problem is like, how do we get, well, you know what? I'm going to do it as a factor because I don't want to write all that stuff out. So forgive me. We'll come back up here to where we have the data frame. And I want to make condition a factor. And so we'll go ahead and pipe this into a mutate on condition to make that a factor. And then we'll do condition. And then our levels will be the levels of the unique values of condition. And so I think then we can pipe this in and it should be in the right order. Yeah, so I'm basically using the inputted order where, let's see, if we look at what we had here for pivot longer, we see that we have the wild type and then the mutant, the wild type and the mutant, right? And so I'm basically in here using that order to seed the factor order. Okay. All right. Great. I'm glad you're seeing these for the first time. Wonderful. Daniel from Mexico, could you remind us in which cases you would use chord transform instead of scale y log 10? So to be honest, I very rarely use chord transform, but let's look at the help. Isn't it scale transform? Let's do the one you suggested, chord transform. It's chord underscore transform. And so this, I think, is a more generic version of what I'm using with like scale X or scale Y log 10. So with chord transform, maybe I've never used this actually. Yeah, I think my recollection is that this is a more general version of transformation, that you can give it any function to transform it. I know I want to use log 10, but say you weren't sure if you wanted to use like log 2, natural log 10, arc sine, square root, right? Then there are other more generic functions like chord transform that would allow you to do that. I might be wrong about that, but that's my sense. I've never used chord transform, at least not that I recall. So I would use scale Y log 10. But sorry if that's not a very helpful answer. So, all right. So we've got things in the same order that they have. Let's go ahead then and fix the labels on the x-axis. And so for this, we're going to go ahead and do scale x discrete. And here then I will do labels. And we'll do hyphen, and then we'll do E2, and then K. But we need to repeat it twice, right? And so let's try using the rep function. So basically, this is a lazy way of copying this vector twice. And now what we can see is that we've got the hyphen, the E2, the K, hyphen E2K. Cool? All right. Nice. I don't know if you think it's worthwhile, cool. Otherwise, I don't know. I'll let you filter yourself if you want to pipe up with other methods. But yeah, and so cool. Now I'm trying to think about what to do next. So we've got our x-axis styled. Let's go ahead and style our y-axis. Okay, and so we've got scientific notation, but you can see it's quite a bit different from theirs. And so to get theirs to work, we need to have a superscript. And there are ways within R to use a superscript, but they're really kludgy and really hard to use. And so what I prefer to use is library ggtext. And so I love library ggtext because it allows you to use HTML, Markdown, CSS to style things, right? And so like, for example, if you look at this tag here, the delta SRL AEB, the delta is a normal font, whereas SRL AEB is italicized, right? Or this P is italicized, but the rest of it is not italicized. If you want to do that mixing and matching, it's really nice to be able to do that with ggtext. And so to do that, let's go ahead and do theme, and then we'll add in what? So that's going to be the scale, not scale, axis text.y. We'll do element markdown, right? And so that is the function instead of element text that allows us to use markdown, like CSS, markdown, HTML to style things, okay? And so then in my scale y log 10, what I will do in here, we'll have breaks. And to match their breaks, I'm going to do 10 to the, and then we'll do 2 seek 2 10 by 2. Okay. So what this will do, if I run this, will give me those values, right? And then my labels, oh, I think I got in the wrong spot. right? And then my labels will be 10 to the, and this is actually going to be a paste. So we'll do paste. Yeah, and then here we're going to put in our soup. And this needs to be in quotes, right? Actually, let's do this with glue. Glue is a handy tool. It comes with the tidyverse. It's a handy tool for doing things like paste, but easier. So we'll do glue, paste 10 soup, and then in curly braces, we can put our code. So I could put this same sequence, close curly brace, and then close out the soup tag. Okay, and then to show you what this will look like, if I run this, we get these values, right? And so it's embedded the number within the string, right? We could have also done that with paste or paste 0, but let's try this. And so now when we run this, what we get are our numbers going from 10 to the 2 up to 10 to the 8. Theirs goes up to 10 to the 10. Actually, one of the things I didn't like about this was that their limit of detection is 200. And so I would prefer to go down another log to make it clear like that this number was on the limit of detection, it's at the limit of detection, there's nothing below the limit of detection. It's a subtle point and you might not care, but let's go ahead then and do limits, or, well, let's change the breaks first. We'll go from 1 to 9 by 2, 1 to 9, oh, I think I did 8. 1 to 9 by 2, there we go. And so now what we see is that we've got the 3, 5, 7, 9, but we don't have the 1. And that's because our limits aren't right. So in here, I could do limits, and we're going to go 1e to the 1 to 1e to the 9. And so now what we see is that we've got 10 to the 1, 10 to the 9. Okay? Cool. And something I notice about theirs is that 10 to the 2 and their 10 to the 10 are right at the limit, right, of the axis line. There's no padding like we have here. And I'm kind of planning ahead here. So I could turn that off within scale y log 10. I'm going to turn that off in chord Cartesian because I'm going to want to use that on the x-axis and the y-axis. I'm also going to want to plot data outside of the panel, right? So like this text, this text, this text, these anchors, the p-values are all going to get plotted outside of the panel. And so I need to set that up in chord Cartesian. So we'll do chord Cartesian. I'll do clip equals off, expand equals false. So doing that, we now see that we have 10 to the 1 right at the edge, right? We don't have the gap going down below there, okay? But like we might want a little bit of expansion on the left and right sides. And so this first hyphen is at 1, 2, 3, 4, 5, 6, right? And I think I made my width 0.8, right? So it goes from like 0.6 to 6.4. So I'm going to go ahead and come in here and then do xlim from 0.5 to 6.5. And this will actually add back a little bit of padding to the right sides of the plot, right? And so you can see that there. Because I'm also going to be plotting data outside of the panel, I need to move the limits for the y-axis out of scale y log 10 and put it into chord Cartesian. And so this will then be ylim. Okay. And so nothing changed there, and that all looks good. All right. Great. Let's go ahead and do some changing to the themes to make it look a bit more attractive. And let's start, because we've already got theme in there. Let's do theme classic. So theme classic is a built-in theme that has a white background, no grid lines, and has solid left side and bottom side axis lines. And so there you go, right? And so that's great. One thing I noticed with mine now, instead of the prism plot being much clunkier and darker than ours, mine's clunkier and darker than theirs. So I like that thin look. So we can modify that in here by doing axis.line, element line. We'll do line width equals, let's start with 0.2. And so I think that's pretty good. It might even be thinner than that, but I think that's good. Our ticks are still thick. So let's come in here and we'll do axis.ticks equals element line width equals 0.2. There we go. Cool. And I think their ticks are a little bit longer than mine. And so we can do that also by doing axis.ticks. Actually, it's axis.ticks.length, and then give it the unit function, and we'll do 3 points. Let's try that and see where we go. I'm not sure if that changed. Let's go up to say like 4. That might be too wide. Let's go back to 3, and I think that'll be good. I don't know what the default length is, but I think that's good. All right. Cool. So I'm kind of pausing before we go into adding some of the extra annotation. Let's go ahead and add in the labels, okay? And so we're going to want to get rid of this condition because we're going to do something else on the bottom. The left side we're going to want to change, and the top will be a title. The title at the top will be the invasion, right? And so let's come in here and, where to put this? I like to keep all my scale stuff together, all my geom stuff together, all my labs together. So do labs, x equals null, y equals invasion. Yep. And then, or not y, that's the title. So let's move that to the top, okay? And then y, they have this. Can I copy and paste that? Not very effectively. So we'll say endpoint of invader. Okay. Did they hyphenate endpoint? Yeah. Endpoint of invader. And then to get it to be on a separate line, we could use a line break, or we could use the HTML BR tag. Because again, I'm going to have that superscripted -1. I'm going to use element markdown again, like, to get that. One of the things I noticed in the critique video was that they use CFU ML to the -1 versus CFU/ML. I thought that was interesting. For whatever reason, I always use a slash if I'm, I don't know, doing a density like this. So I thought that was cool. So we'll go ahead and do the BR break. And then in parentheses, we'll do CFU ML soup -1 soup. And then that needs a closing parentheses. Okay. So one thing in the critique video that I commented on was that at least in the other panels, they have a unit as the title, CFU per mil. This would be like in the x-axis, instead of having time hours, they just wrote hours, right? So I would prefer to have a title and then put the unit in parentheses, right? And so they've kind of done the same thing here. So endpoint of invader, endpoint what of invader, right? So I'm going to go ahead and do endpoint density of invader. Oh, and I forgot to add a plus sign here. I think I heard someone silently cringe as I forgot that. So sorry. There we go. And so there we go. So there's all my HTML. There's invasion. So we need to style that, right? So we'll go ahead then and do axis.title.y equals element markdown. And I'll go ahead and put this back up here at the top. And so now we've got that off to the left. Cool. The font is too big. We'll deal with that here in a minute. And then the title invasion is left justified. So we can change that also And I'll do that up at the top. I'll do plot.title equals element text. We do hjust equals 0.5 to get it to be centered. Okay, so now that's centered. Our fonts are too big, but I want to use the font that they're using or something like it. And one thing that stands out to me as being a bit different than my font, their font seems more rounded, like the O of on theirs is more of a circle versus an oval with mine. Their L has kind of a tail. So let's go to fonts, Google, and I'm going to go ahead and, let's do CFU mill, something like that. And I want a sans serif font, right? And so what I'm looking for is something like this tail. And I was looking earlier and I thought I found one that looked kind of cool. So like this railway looks good. Or maybe this Nunito Sans or Nunito. Let me put in invasion and come back to that Nunito Sans. Oh, where are you? There we go. And let's see. Nunito. I think that's close enough. Let's use Nunito. All right. So to use that font, we're going to come back and add another library. We'll do library show text. Make sure we got that loaded. And we'll do font add Google. And it'll be Nunito. And then the family name will be Nunito in lowercase. That's good. That loaded it. I would have gotten an error here if I'd have used the wrong name, right? If I used like Nunita or something like that, it would have been like, I don't know what that is. So we'll then do show text opts. I'll do DPI equals 300. That's the resolution that I'm building this plot in. And then we'll do show text auto to go ahead and get everything accessible. And so now I can come back down here to my theme and I can do text equals element text, family equals Nunito. And that should use the Nunito font everywhere. And you can now see that we've got that tail on our L. I'm noticing that like the one has a base on it, whereas theirs doesn't. Oh, that doesn't really matter. Let's do L minus 1. Let me just see real quick. I don't want to spend a lot of time on this because it doesn't matter. Yeah. Yeah, I'm not gonna worry about it. All right, we're gonna move on. They may have used some like proprietary font, but I think the point here is to show that we can change the font. Okay. One other thing I'm noticing, like our hyphen here is pretty short compared to theirs. And I think what we actually want is an M dash. And so let's do Unicode long dash. And I think I've been here before. I want to grab the Unicode. So it's going to be /U 2014. And so back up here where I had that hyphen, I'll do back U 2014. And so the back U tells R to use Unicode. And so we're going to use Unicode character 2014. And so now if Nunito has an M dash, we'll get it. So hopefully it has an M dash. There we go. It's got an M dash. And that's actually quite long. Actually, it's not an M dash. That's a long dash. So let's see M dash. I guess that is 2014. All right. Whatever. That's fine to have the long dash. We'll be okay with that. Okay, let's try the, I can't help myself. Let's try this FE58, because I think that is, yeah. We'll try it, and if we don't like it, if I don't like it. We'll change it back. And we get that box, which means it doesn't have it in the font. So we'll go back to the 2014, and I think that's cool. All right. So now, again, our fonts are too big, right? And we know that our fonts are too big because the left title, the y-axis title, is running off the screen. And so we can come back to axis title y, and I can do like size equals 8. And so now we can see that that really shrunk down. That looks nice. We can maybe go a little bit smaller. I don't want to go too much smaller because I want it to be readable, right? So that's what 7 looks like. So let's roll with that. And what I'm noticing is that like all of the fonts in this plot, I think, are the same size. So everything is going to be a 7-point font if we do that. So let's do size equals 7 on the title. And then like for axis text, well, we'll have to do a text X and a text Y. Or no, we don't. Too much. So we'll do axis text, element markdown, and then we'll do size equals 7. And so that means the X and the Y will both be size 7. And I think that's all the text elements. And it didn't like my axis text. I think this needs to be .y. And then we need to do a .x. Okay. There we go. What happens within the theme function is that things are hierarchical. And so like axis text y inherits from axis text x. And so if within theme classic axis text y is already defined as element text, then sometimes it doesn't inherit down. And so you have to be explicit about what you want. And so here we go. We've got that font, and maybe the y-axis is a little bit too big. Maybe it should be a 6. Makes me nervous to get too small because I want it to be readable, right? I think it looks good. Okay. And again, what I'm thinking about readable isn't necessarily on the screen because I can always zoom in and make things bigger, but I'm thinking about printing and what things look like when you print them out. So anyway, so all right, great. Now what we want to do is to start bringing in the brackets, okay? And I'm moving a little bit slower than I'd like, so I need to kind of speed things up a little bit. All right, so the first thing I want to do is the bottom. And so the bottom bracket for the resident and then the invader toxin label, I need to add some margin to the bottom of the plot. All right, so we'll do plot.margin equals margin. Let's do b equals 20. And it's going to turn all the other boundaries to 0. So let's do like t equals 3, r equals 3, b equals 20, l equals 3. Okay. And so that then gets us this extra space down here at the bottom. And I think that'll work. We could then go ahead and let's go ahead and add in the text. Now, normally, if I only had like 2 text elements like this to add, I would use annotate. But because I want to use Markdown, I need to use geom rich text, which comes to us from the GG text package. And rich text doesn't play well with annotate. So let's come back up and put that under my scale X discrete. So we'll do geom rich text. And then we'll do data equals, and I need to make a tibble. So the X position will be like 2 and 5, right? And then the Y position, you might be tempted to say 0 or negative, right? But again, it's still on a log scale. So let's try 0, let's try 1, okay? And I need to put that Y within the tibble. So this needs to be C2, 5, y equals 1. And I know there is a package out there, I don't know if someone's saying that, that will allow you to make the breaks, but I want to do it this way because I know how to do this, and there's always this trade-off that I talk about in a lot of these videos between learning a new package for like one little thing that is actually complicated to use in that other package versus using other tools that I already know pretty well and that I use for lots of things, not just like these one-off things. And yes, we will be getting to, yeah, so I think that's what you're asking about the gpub. So I'm going to hold off on that, and maybe in the future I'll dig into that. So this gets us our tibble. We also need to put in here then the label, and we'll do wild type, and then we're going to put in our mutant, right? And so there's a HTML delta semicolon. So the ampersand delta semicolon will get you an uppercase delta. And then in italics, so a star, we'll do SRL AEB, and then close star. And need a plus at the end of this. And then we'll do, oh, I think I've, all right. And then we'll do AES, X equals X, Y equals Y, label equals label. And then we'll do inherit.AES equals false, which basically means don't be concerned about not having the same columns that we had back up here in this other AES statement, okay? And there we go. We now have our label, and it's got a border around it, but we can see that we put it at 1. This is at 10, so we probably want to go down to like 0.1. And we want to get rid of some of that stuff. So let's do 0.1, and then also we'll go ahead and do family equals nunito. And then let's do size equals 2 to start. So within geom-rich text, the problem with it is that the size isn't in points, it's in millimeters, which is a pain. So you kind of have to match things the best you can. And so, all right, let's go ahead and get rid of the label elements of that. And so we'll do fill equals NA, and then label color equals NA, and then label dot padding equals, we do NA? Nope. We have to do unit. Let's see. I lost you. Where'd you go? Right here. So we'll do unit 0 PT. And so the padding is the area around the text within the line, okay? And so that font is maybe too small. So let's take it up to, say, let's try 3. Okay, too big. So let's go to 2.5. I think that's good. Let's try to move it down a little bit. And so, where'd you go? Okay, so let's do 0.5. That's good. That's pretty much at the bottom, okay? So we've got those 2 labels in there now, okay? And I'm happy about that. Now, since we're thinking about text, let's go ahead and add the invader toxin and the resident. And we'll go ahead and do, I'll do annotate here to show you what I would do with the annotate function. We'll do geom equals text. X then is going to be 0.5, right? Because remember, I set my X limit at 0.5, right? And then my Y, I want to be aligned with these labels, right? So let's try 2. And then what I used up here was 0.05, right? And then label, we're going to do invader toxin, and this needs to be in a vector, and then resident, right? Yep. And then add all that in. Let's see what this looks like. Cool. So I think that stuff is more or less in the right place. Of course, we don't have the font we want. So let's go ahead and do that. So we'll do family equals nunito, size equals 7. It's using 7 millimeters. That's the default size. So with geom text, I could then do size.unit equals pt to get it to be 7 point, like that. I don't want it to be centered at 0.5. I want it to be right justified at 0.5. And so we'll come back up here and we'll do hjust equals 1 to make it right justified, like so. But of course, we've lost the left side of invader. So let's go ahead and add some margin to the left side. And I did that in theme under plot margin, right? So let's try 10. And there we go, it's back. Cool. Nice. So we've got those text elements in. Now we want to add the bars, right? These brackets. And again, has been brought up by Ibrahim and others, you could use ggplot2 to do these types of brackets, but I want to show you how to do it manually so that you don't have to worry about another package. So we're going to do this also with annotate. And my hope is that by figuring this out with invasion, a lot of the stuff will transfer over to the displacement panel. Okay, we can make a function and then copy it over. All right, so let's go ahead then. In here, we'll do annotate geom equals segment. And then for geom segment, we're going to need x and xend. Well, we don't need, let's start with the horizontal bar. So we don't need an xend because by default, it'll use for xend the value of x, right? So for x, we're going to go from 0.6 to 3.4. So 0.6, 3.4. And then y, so y then, oh no, I screwed that up. I do need an xend. So this 3.4 is the xend. 3.4. And then it's the y that doesn't change because the y at the beginning is the same as the y at the end. And so this is going to be between my wild type, my resident label, and my x-axis label, right? And so my x-axis label, the y position is 0.05. So let's try it at 1 and see what we get. And we'll try one segment and go from there. And so there we go. There is our segment. We need to pull it down and make it thinner. So let's try 0.1. So the hard part about this is that things are in log scale. I'm not used to thinking in log scale for kind of how to position things. So let's maybe take this up to 0.3. I think that's good. Let's go ahead and make it thinner. And we'll do line width equals 0.2, which is what I think we've been using for our other line widths. Well, that was 0.1, but I guess I had line widths down here of 0.2. Okay, so let's try that. And so that's nice and thin. Let's add in that horizontal line for the other one. And so then this is going to go from 3.6 to 6.4. And there's our second line, okay? Now we need to put the tails, right? And so we'll do that with another geom segment within annotate. And let's go ahead because we know we're gonna do line width equals 0.2. So again, we want x, and so we're gonna have x and xend, and now we are going to have y and yend because the y is going to start at 0.3 and go up a smidge, right? So our x positions, we're going to have 4 of these segments. So we're going to have like 0.6, 0.6, 3.4, 3.6, and 6.4. And here now, the xends are going to be the same as our x's. And so maybe we don't actually need to say the xend because that's going to be consistent, right? So then our y is going to be 0.3 for all 4. And then our y end, let's do 0.5. And this needs to be a vector. All right. Wow, I got that right. That looks pretty good. I like that length. What happens if we go up? Well, I could make the y, well, I actually don't need all these vectors, right? I could do like 0.3 y end equals 0.6. Oh, I forgot a parenthesis at the end here. Yeah. Maybe that's a little too long. Let's do this as 0.5. So what I'm doing with like the single value here of y and y end is basically telling R to use the same value, to repeat the same value. It's called recycling. That's what the R jargon is recycling. And so we've got that bracket now. I think that looks pretty good. What do you think? All right. Now what we want to do is think about the p-values. And we need to get the p-values, and then we need to draw them in. But it's basically going to be the same thing that we did with these labels at the bottom for resident, right? So let's come back up here, and we're going to have to do some experimenting. And I think we're going to have to pull this apart. So I'll call this F data. And I'm trying to think about where I'm going to split things off. So if I do it here, right, if I do that, and then that, nothing changes. Okay, good. So let's think about F data. And what we want to do is a hypothesis test between the no invader toxin and then the 2 toxins for both the wild type resident and the mutant resident, right? And so they used what they said was the Mann-Whitney U test. If we do Wilcox test, this is a 1 and 2 sample Wilcoxon test on vectors. This is known as a Mann-Whitney test. And so I think what we'll see is that we might get slightly different values than what they got, but we'll roll with it. So again, we have F data. And if I wanted to, so what I'd like to do is to make this dry. So don't repeat yourself. So I'm not repeating the same thing. So we're only doing 4 tests. So it's not a big deal to repeat ourselves in this case, but I'd like to kind of, I don't know, we'll see. So let's do it for 1, right? So let's do filter, genotype equals wild type. And then we'll do toxin equals E2. So I'm going to put this in parentheses. So do E2 or toxin equals a hyphen. This gets us not what we want. And that I missed. It's call E2, not E2. Okay. So now what we see is that we've got the toxin with and without the toxin for the E. coli, right? And so now what we could do is we could pipe this to Wilcox test, and we could give it the formula specification. We could do density tilde toxin data equals period. And that data equals period means take the data that's flowing through the pipeline and use that data, right? And so we get output. So we get a p-value of 0.2856. And so, again, wild type, no invader versus E2, they got 0.2832. Again, slight differences. There might be slight differences in what's going on under the hood. Reading through the documentation from Wilcox test, it seems that there's a few versions of the Wilcox test and a few versions of the Mann-Whitney U test. I don't know what PRISM uses. I'm also assuming that the original authors used it correctly, so whatever. We're also getting this warning message that it can't calculate exact p-values with ties, I can get rid of that by doing exact equals false. The error warning goes away because I'm not going to calculate exact p-values. That's fine. I want to get this p-value out. So let me go ahead and pipe this to str. And this tells me the structure of the data. And I see that it's a list and that there's a seat in that list called p.value. So I can then do pluck. I think I can do p.value. I don't remember if I need quotes around that or not. Yes, I do need quotes around that. So pluck works within a pipeline to get elements out of a list, right? So that's our p-value, right? So I could repeat this and then do call k and get 0.06, which is this. They've got 0.549, right? And then I could keep going. I guess I have 8 tests, right? And so I'm thinking, like, is there a way to pipe this to do it with like a map function, right? So again, if I have invasion, fdata, I could nest. So I want to nest, right? And I'm trying to look at the time and look at what we're doing here. Let me spend maybe 5 minutes and see if I can figure this out. And if not, I'll write the 8 tests. Great to have you, Hassan, joining from West Virginia. Thank you. Great to have you. So I know that I want to nest in there the density, right? And so let's clean some stuff out of here that I don't know that I need. So let's select, what do I need? I need the genotype. I need the panel, the genotype, and toxin, and the density, right? And so what I'm thinking is I could pivot wider the toxin. Yeah, let's try that. So do pivot wider, values from equals density, names from equals toxin, and it's upset. And it's giving me, for my invasion, it's giving me these lists, right? And so I think what I want to do is nest data equals everything but density, or everything but, well, that didn't work. Maybe I want to nest the density. Okay. And so that puts density into a list. Like each value of density is its own list, and you can see that they're different lengths, which is what this was complaining about up here, right? They're not uniquely identified. It'll contain list calls, right? So whatever. So now what we could do would be to pivot wider that, and it's complaining that density doesn't exist. So let's pivot values from data, names from toxin. All right, there we go. So now what we could do is we could, we can iterate over each genotype. So we could do that with a mutate. So let's do PE2, and that will be map. We're going to do a map function. I'm going to do a map2 because I'm going to give it the hyphen column and then each of the colocin columns, right? So we'll do map, and then the dot x will be the hyphen, and then the y in this case will be call E2, and then we'll do Wilcox test, and we're going to give it the 2 sample, right? So that the x is going to be dot x, y is going to be dot y. So the dot x is going to be the data from the hyphen, and the y is going to be the data from this. And then kind of like we saw up here, well, in here we can do exact equals false, and then we can do pluck p dot value. Let's see what we get. All right, so it's upset. X must be numeric. And I think that means I need to unlist this, right? Because X and Y, or the hyphen and the call E2 are lists. So if I do unlist on these, I hope it will work. It worked. And I'll clean this up here in a minute. I'm excited to see the result. So we'll do unnest on PE2, 0.286, 0.606. Cool. And so again, those two p-values, the first 0.286 is this one here, the wild type hyphen to E2. And then the second one, 0.606, they've got 0.5897. Okay. So let's clean this up. And oh, there's a lot going on here. All right. Okay, so that still works. And so we want to do the same thing, but for K. So I'm going to copy this and do PK, call K. And then we'll do unnest CPE2 PK. Oop. And I must have forgotten a parenthesis somewhere. No, let's try this again. It's unhappy. Why are you unhappy? Don't be unhappy. All right. Oh, because I'm missing. Let's see. Somewhere I'm missing a parenthesis. So that's right, I think. That's right, I think. Let's see if this works. Okay, so there's my PK, PE2, PK, unnest. Oh, I'm forgetting a parenthesis at the very end. Somebody actually said that. Let's try it again. Okay, there we go. Now we've got our PE2 and PK. So very good. And there are p-values for our panel and our genotype. I'm going to go ahead and clean this up. We'll do select panel, genotype, PE2, PK, and I'm actually going to rename these to be, we'll call it call E2 equals PE2, and then call K equals P underscore K. And so that gets me that. And so now what I want to do is I want to make a data frame so that I can plot the p-values, right? And so I want like a pretty name, right? So let's go ahead and do, yeah, so we'll go ahead and do a mutate, and we need X positions. And so the X position for the wild type E2 will be, so this is 1, 2, so that'll be 1.5, right? 1.5. I need to pivot this to get it to be wider, to be longer, right? So we'll pivot longer, and we'll do names from what? Oh, I have to give it the columns, right? So I'll do C call E2, call K, names 2 equals toxin, values 2 equals P. So that's tidy, right? And so now I want to add X, and I'm going to add a vector of values. So for the wild type, we have for E2, we're going to have 1.5, and then we're going to have 2.5, right? And then we're also going to have for the SRL, this is 4.5 and 5.5, right? And then we need a Y position, and the Y position, oh, I'll call that like 1e to the 6, 1e to the 7. We'll adjust. And then up here we have like 1e to the 9, 1e to the 10. Okay. And then we want to do pretty p, as I always do. And here again, we'll do glue, and we'll do p italicized equals, and then in the curly brace, p, right? And that's going to take that value and put it in there. And so looking at what we have here, oh, what are you unhappy about? Oh, I forgot to add a pipe to the end of this. There we go. And so now we've got our pretty p. Those are, of course, very long. I think what I'll do is signif on p2. And so that gives me 2 significant digits for each of my p-values. All right. So now I will call this p-values. And I will then come down here and we'll add that. So let's do geom rich text. Data equals p values. And then AES, X is going to be X, Y is Y. Label is going to be pretty P. And we'll do inherit AES equals false. And then we'll do family equals nunito. Size equals 2.5, I think was what I had used. Oh, 2.5. Okay. And then we need to turn off, oh, where are you? All this other stuff. I'm going to copy and paste this down to get rid of the label, basically, right? Get that in there. Get a plus. And bam. We've got our p-values. All right. So I think we can maybe, so we need to add more space between the title and the panel. So let's start there. So we have plot title, and let's do margin equals margin, b equals 10. Let's do more. Let's do 20. Oh, it's making a lot of stuff look really bad. Let's stop there because my title over here is kind of running into the invader toxin. And let's go up to 25. Yeah. This is one of the reasons I hate putting these p-values in there, is because it takes up a lot of space. Although these p-values are kind of big. If I make it 2, is that better? Maybe that's better. I think that'll be fine. And then this Y title, maybe I'll put a break between the of and invader. And labs. Oh, where did I put the labs? There we go. I'll put this BR tag right here. I think that looks better. Okay, so let's, these p-values need to get moved up, right, for the mutant. And so I made that pretty p up here, the p-values. So these last 2 values, so let's take this like to 2 and 2. Okay, and go up higher. Let's do 4 and 4. All right, let's do 6 and 6. Oh, come on. All right, I'm gonna do 8 and 8. I'm kind of rushing here. Still feel like that isn't quite the same as what it was down here. And maybe this should be 1e to the 10, 1e to the 11. I'm kind of wondering if it's actually updating what I think it's updating. It just doesn't seem like it's moving a lot. It was moving. Okay, let's roll with that. Okay, I think we'll make that work. All right. Cool. So now we want to draw in those horizontal lines, right? And theirs goes from the middle of the cloud over. Okay. So we'll come back up here, and after the p-values, we're going to do an annotate geom equals segment, line width equals, my fingers, 0.2. X, we're going to be at 1 and 1 because there's going to be this line and this line both start at 1. This and this both start at 4. So we'll do 4 and 4. X, and we'll go to 2255. And then our Y, let's see. Oh, where'd I put you? Okay, so this is at like 1e to the 6, 1e to the 7. I'm going to copy these down for my Y position. And let's see what it looks like. So that's going through it. And I screwed that up. So this should be going from 1 to 2, 1 to 3. So I did 1 to 2, 1 to 3, 4 to 6. Okay, so now we need to adjust the vertical position. And I'll drop these down a log. Actually, you know what? I'm going to leave it like that. Well, yeah, I'll go ahead and do down a log. I think I'm getting tired here. All right. So that is too far down. So that's fine. Now we can adjust. Let's do 2 times. All right, let's do 3 times. And again, what I'm doing is I'm multiplying by a small factor to get that position just dialed in. And I think that is a good vertical position. I'm noticing though that my p-value for the k-test is between 2 and 3 when it should be right over 2. So I want to come back up and change that position. And so I had 2.5, so that should be 2, and this should be 5. There we go, cool. Now we want the little tabs. All right, and again, it's the same kind of thing that we had done earlier with the labels on the bottom. So annotate geom equals segment, line width equals 0.2. All right, and so then again, we need the X position is going to be 1 and 1, right? So this is starting at 1, and it's going to also end at 1, right? And then we'll have a line that starts at 2 and 3. So we'll then do 2 and 3. Why don't I do these in order? So I'll do 1, 2, 1, 3, and then 4, 5, 4, 6. And so I don't need xn because that's going to be the same thing as x. My y then is going to be, let's see, where is it going to start? The y is going to start at, let's see, 4e to the 5, 4e to the 5, and then 4e to the 6, 4e to the 6. So that's the first 4. And then we'll do 4e to the 9, 4e to the 9, 4e to the 10, 4e to the 10. Okay? And then we need a y end. And oh, I'm questioning my choices. Yeah, I'll go ahead and take this. And then let's do 2s. All right. Let's see what this looks like. Waymo. Perfect. All right. I'm happy with that. All right. Thank you for watching, Lori. Cool. So that gets that in. And yeah. What do you think? So the main difference between mine and theirs is what? So I'm noticing somehow I got more margin on the bottom. But the main difference between theirs and mine is I'm making a wider plot, and I've added the density to the y-axis, right? Let me just go ahead real quickly here. And maybe make that 15. Okay. That looks good. Let me know what you think. So then the question is like, now how do we get displacement? And so my thought is I could do this as a function. So let's go ahead and get back to the width, and we'll do library patchwork. All right. And again, we're going to go probably over 2 hours here, so I apologize, but I think we're really close and able to get in the other data. So, so we're going to read in the panel G data and join that to the panel F data. And again, I don't need all these individual tests because now I have this p-values data frame, right? And so we'll have to update this once we bring in the other data. So we're going to have to do some tweaking along the way, but let's go ahead and get in the panel G data. And let me think here. I want to join them together as early as possible. So again, we're going to need this read Excel statement. Oh, but I didn't quite hit the copy. All right, making copies with Pat. I don't know if you remember that Saturday Night Live sketch or not, but yeah. So panel G starts in B52. So we'll update our range here and goes down to G61. All right. And so that read in gets all that stuff, right? And so I think what we could do is we can actually come all the way back up to the top here. I'm not sure why I commented that out. And I'll back this out for right now. And we'll do bind rows on that and that, right? So this then reads in both ranges and adds them together, right? So we had 9 and 9, so it's like 18, right? But I don't have an indicator here of what data set each came from, or which panel each came from, right? So here then I could do like invasion, which I had down below for somewhere, making a panel column. We'll find it. And then the second would be displacement. Right? And then we need to say .id equals, and I'll call it panel. And so now what you see is that we've joined those two together, and we have a panel and a displacement value in our panel column. Okay? So now, again, we want to join stuff together. So again, here was where I made that panel invasion. I don't need that. I'm adding in the replicate. We're going to pivot longer on the panel and the replicate, moving names to condition and values to density. This all works. We drop the NAs, get rid of those, separate wider the genotype and the toxin, right? So then we've got this. Cool. And so I'm going to go ahead and call this panel data, panel FG data. Oh, let's just call it panel data. FG. All right. Call it that. And maybe I'll put these on separate lines so things don't get all wonky on us. All right. Okay, there's panel FG data. And now if we think about this, the p-values, we've got panel FG data. This should work because we're doing things by the panel, right? And it's upset because of this other stuff down here at the bottom. So let's hide that for now. And we'll run this. There we go. And so now we have our p-values for invasion and displacement, okay? And for our genotypes and for our toxins. Cool. So then what we need to do is we need to modify this mutate statement. And it's going to be this, well, similar-ish. So the X, maybe I'll do this explicitly. So we'll write out, so the X positions are going to be the same for both panels. The Y positions are going to be these two upper values, right? So I don't need this lower value, I need the upper values. So I'll go ahead and grab this and I'll duplicate it twice. And so now if I look at P values, I now have my pretty P values, my X positions and my Y positions, right? Cool. And so now we come in here and we're plotting the data. And so this is the part that I think can be a function, right? And so, but the problem, so we could imagine that we could say, oh, I called it panel FG data. So I'm going to call this panel data. And then my panel data is going to be panel FG data filter panel equals invasion, right? So this should work, except it made it nice and wide for me, right? Because I used the full 7 inches. Okay, so but what we're seeing here is that we've got all of the p-values, right, for both panels. So we need to come back up here where I used p-values here, right? And I'm going to make a value that I will call P. And for now, I'm going to call it invasion. I'm trying to build up the arguments and build up the guts for my syntax, okay? So I'll say panel equals P, right? And then if I have that P variable, again, I can come back down to where I had p-values and do filter panel equals P. And now we should, now we have no p-values. Oh, why? So let's see. What's the value of P? Invasion. P-values. Panel. And so the problem is that I've got P and P, right? So I'm going to go ahead and do P title as that. And so then I'll do P title here. And so the problem with having panel equals P is that it's going to look for rows where like invasion or displacement equals a value in the P column. And that doesn't happen, right? So down here then, where I did that, filter panel equals p title. There we go. We've got our p-values and our p-values for that. I'm noticing my title is invasion, and so I need to change that. And so back up where I did labs, right here, I could do p title. Let's run that and make sure it works. Cool, that works. Let's go ahead and turn this into a function now. And let's see. Yeah. So we'll go ahead and do plot panels fg function, and we'll say data or panel data. Yep, panel data, and then p title, and then our curly braces to define the body of the function, and then we'll tab over and close out the body of the function, and then we'll take all this good stuff, cut it, bring it down, and so then we're going to do plot panels f and g, and we'll do what? You know what? Why don't I send it panel fg data? I can put this in the body of the function, if that makes sense. Hopefully I know I'm going fast here because I'm right at 2 hours, but hopefully you'll be okay with that. So this will be panel data. Oh, what am I doing? Okay, let's try this again. Okay, so we need to get it panel data and then p title. Does this work? That works. Cool. But like we'd like to do this for the other panel, right? And well, we saw we could do this with patchwork before, right? So let's do that. So we have panel fg data. All right. I don't think I want to do that with Patrick again. With the map. Trying to think here. If we gave it panel fg data with p title, let's see. So we give it the full data frame. You know what? We probably don't need to even worry about the data frame. And panel fg data filter panel equals p title. And we'll get rid of this argument because it'll know to grab it from the global environment, right? And panel data is down here. Okay. So now what I should be able to do is run this. Okay, let's try this again. Okay. That works. Now let's try it for displacement. Right? And we could even add them together with Patrick. And there we go. Cool. Right? So our lines here aren't in the right place for displacement. They need to get moved up. And then also over here we have invader instead of, I think, resident. Resident, which it had there. Okay. So let's go ahead and make those subtle tweaks and then we'll be done. I think this will take 5 or 10 minutes. All right, so we'll come back into our function, and let's start what I think will be easy. And let's do y-axis tag. So we'll say if else p title equals invasion. Then we'll say invader. Otherwise we'll say resident. So invader and resident. Yep, invader and resident. And then we can come down to labs, and we'll again use glue here around that label. And we'll put in here our y-axis tag. Let's see if this all works. Yeah, and so we have invader on the left, resident on the right. Good. I'm feeling like our label here has kind of like crept up a little bit with kind of messing around with some of the margins. So let's see, that was that. So that was a rich text right here, right? And so our y was 2 and 0.05, sorry, 0.03. Oh, that was the wrong one. Not 0.05. This will be this one here. So let's do 1.5. Let's do 1. And so that brought that down a little bit. I think that's better. Okay. I like the addition of outputs of the function with the different inputs. When you've only got 2 panels, it's a lot more straightforward than map. Yes, thank you, Mike. You you validated my choice to not go off the rails. I am worried. Let's go ahead, and I think it's and theme margin equals margin zeros all the way around. Oh, right. It's plot.margin. Oh, sorry. I put the plot dot in the wrong place. Yeah, that didn't do what I wanted it to do. Is it the ampersand? I'm trying to fly blind here a bit. All right, let's leave that off for right now. And let's get those lines in the right place over here, right? And so those need to be, for displacement, they need to be in the same place as they were on the right side. And so we have these segments, right? This is where we defined that stuff. And so I think what we want to do is kind of like what we had up here, right? So we'll do sig lines. So if, well, yeah, we want to do like if else p title equals invasion, then we're going to give it values. Otherwise, we're going to give it values. The problem is that if else can only return a single value. It can't return a vector of values. So I think what we'll do is grab those values for, let's see. So it's these segments. So I'm going to go to copy this and bring it up here. And I will comment it out so I don't confuse myself. Okay, so the sig, we really want to change the sig line y, right? So if it's invasion, then it's going to be 1 to the 5th and 1 to the 6th, right? Otherwise, it's going to be 10 to the 9 and 10 to the 10. Yep. And that's for those first 2 positions, right? Although, is that right? Right. Oh, no, this is 4 and 4 and 4 and 4 because I multiplied all these by 4. All right. And so, again, but we can't do this with an if else, right? So let's by default say sigline y equals 4e to the 5 and 4e to the 6. And then we can do if p title equals displacement, then we'll do a curly brace, and then we'll do this, and we'll do sigline y equals that, okay? And just kind of thinking here, so then like the y end is half of the y sig y line, okay? So let's come back down here then, and I'm going to turn these all to 4s instead of doing the multiply by 4 because it's going to make things confusing. And so here then, this is going to be the sig line y, right? So because we're just replacing those first 2 lines. And then, again, that's these values here. So then here, we can do sig line y, and we could do like rep on sig line y 2, but that's going to take sig line y and then repeat it twice. I want to do each twice, right? So again, if like sig line y, if sig line y is 1 and 2, right, and I do rep sig line y each equals 2, then I get 1, 1, 2, 2. But if I do 2, I get 1, 2, 1, 2, right? So I'm going to do each 2. And then here, I'll replace the y ends with that, and then that divided by 2. Fingers crossed, this should work. Yes, it worked. I'm happy. All right, and it took me 8 minutes. So with the extra 2 minutes I said it was going to take me, I'm going to go into Patchwork and see why, how I can change the top and bottom margins. And so I think it's in annotation and style. And so like what we had done was that ampersand. So plot annotation. And so this is for the overall plot. So let's try that. So we can add that. And we don't want the title, we want the theme. And we want plot theme, plot margin, and we'll do margin zeros all the way around. Bingo. That then got rid of the extra margin that we were getting from Patchwork. Patchwork was adding a margin around the whole thing, which I'm not really ready for. Maybe we could add a little bit of space in between the panels. And one way we could do that is to come back up to plot margin. And like on the left, I made it 10. Maybe we make it 20. And oh, maybe we split the difference. So that had been 10. And R was 3. So maybe we add like 5 to each. So we'll do 8 and 15. Because it's adding it to the right side or to the left side. It's adding it to the left side of the panel on the left also, right? And so I think that's better. I like that. So I'm very happy we got this through. I know there's another package or other packages to do the statistical testing. I've addressed some of the critiques that I had, while I think staying very true to theirs. Oh no, oh no. I noticed a problem. I have to fix this. The problem is in displacement. It's still doing the fill by the invader toxin rather than by the genotype. Rats. All right. I think what I'll do is I will modify that. So if we come back up to here, so if we come back up to what? Well, if you want to stick around, stick around. I think we're done, except for the fact that I've got the wrong labels here. And part of me is thinking, what is the easiest way to do this? Because these should be gray, and these should be white, right? And that's because the resident doesn't have a toxin, but the invader does. So this is going to be white, and then these will be, all three of these will be gray fills, light gray fills, because they're the mutant, they're the knockout. Sorry, I just noticed that. And so let me think about what I have. So I've got panel FG data, and we are mapping condition to the x-axis, toxin to the fill, but we're also using the toxin to do the p-values and the genotype to do the p-values. So if I do something on the toxin, I want it to be after. Maybe we can create a separate variable than toxin to do the fill. I think that's what I'm going to do. So I will come in here and get rid of this. Sorry, I know this is going longer than most people bargain for, but okay, let's do it up here. So we've got panel FG data, and then we can maybe make to mutate fill variable, nice generic name, and we'll do let's see. So let's see. Yeah, so if else panel equals invasion, then the is going to be toxin, right? So we're going to fill by the toxin. Otherwise, we're going to fill by the genotype. Okay. All right. And our p-values still work. Cool. And then we want to come in here, and our ggplot, our fill, is going to be on fill variable, right? And then we're going to have to change scale fill manual. And again, thank you for this tip. I forget who you were, but wild type will be white. And then I believe it is SRL will be gray. All right. Hey, it worked. Okay. So now we've got the right fill colors. So let me go back to concluding. So we have made basically the same exact plot, the same panels, F and G, using the same height. So this will not make the figure taller. It will make it wider. But as I showed you in the PDF, it was only using like 2/3 of, or maybe 3/4 of the width of the page. And so by separating it like this, we get more space to see the data, right? So that's one aspect that I changed. Another aspect I changed was to use only 2 significant digits in the p-values. I think that is plenty specific enough without going out 4 decimal places for all of these. The other thing I did was to add the variable, the density, to the y-axis labels. Okay, and of course, instead of doing this in Prism, I did it in R. And again, I'm noticing another small problem that I will quickly change, which is this line for adding in the limit of detection. And so I will do that. And that appears to be behind the point. So I'll come in here and do geom hline. There's always like one more thing. I think this is it. Y-intercept equals 200. Line width, I'll do 0.2. Color, I'll do gray. I prefer to have a fairly non-intrusive line for my limit of detection. And so, again, I think this line for limit of detection is not as prominent as theirs is with the dash line. I think their dash line might even be thicker than their axes, which calls greater attention to it. Whereas mine is here, it's there, it's thin, and it's not as obvious. And I think that's good. So, all right. So that's it. Again, I am very sorry for taking so much of your time here. Really appreciate anybody that has made it all the way through to the end of the video. I hope you have learned something today, learned a lot. I know I have learned a lot. Using those named vectors in those scale functions, I think is really awesome. So thank you for that. And yeah, so I hope you have some ideas for things that you can incorporate into your own data visualizations, things you can practice with as you continue to learn R in your own journey. Next week, I will do another live stream where I think I will go ahead and do panel C, D, B, C, D, and E. And so we can then combine those together and maybe add in the panel labels like they had in the original. All right. Well, thanks again. And I will see you next time for another episode of Code Club.